In this video, I want to find the Thevenin equivalent circuit for this resistor R3. So our Thevenin equivalent circuit will be a circuit like that with V Thevenin, RT, and R3 or R load. So the first step is step one. Step one is to find V Thevenin equal to V of open circuit at that point. So if we do that, then we are going to have V1, R1, R2, then open circuit in here, and we are going to have V2. Now, by looking at this circuit, this is point A. Our voltage at point A will be V1, which is 42 volt. And on this point, this will be our point C. Our voltage at point C is equal to V2, which is 35 volt. And in order for us to find the voltage in this open circuit, we need to find the voltage at point B. Then we have the voltage at point C and point B, then we can find the voltage in that open circuit. So here at point B, we are going to have 1 over R1 multiplied by VB minus VA plus 1 over R2 multiplied by VB equal to 0. So here we have voltage at point A, which is 42 volt. We have R1, we have R2. The only thing we need to find is voltage at point B. So here the voltage at point B multiplied by 1 over R1 plus 1 over R2 will be equal to 1 over R1 voltage at point A. So here we are going to have VB times R1, R2, R1 plus R2 equal to 1 over R1 VA. So here we are going to have VB will be equal to VB will be equal to R1, R2 divided by R1 multiplied by R1 plus R2 VA. So our VB will be equal to R2 divided by R1 plus R2 VA. So if we plug those values for R2, R1, and VA in this equation, we will find the value of VB to be 14 volt. So the voltage at point B here will be 14 volt. And the voltage at this point is 35 volt. So the voltage on open circuit will be VB minus VC, which is 35, which is going to be 14 minus 35, so it will be minus 21. So here, our voltage VT will be minus 21. Now the second step is to find the RT. And to find RT, we can use a couple methods. The first method is called the look-in method. So let's do the first method first. The first method, so the second step, step 2, is to find RT. And we can find RT by first method is called look-in method. The look-in method is, if this is our R1, this is our R2, so this is the RT look-in method. So we are going to have R1, R2, RT. So 1 over RT will be equal to 1 over R1 plus 1 over R2, which is R1, R2, R1 plus R2. So RT will be equal to R1, R2 divided by R1 plus R2. So if we go ahead and plug the values of R1, R2 in this equation, we are going to get RT will be equal to 4 ohm. So this will be 4 ohm. So this is the look-in method in order to find RT. If we want to use the other method, in second method to find RT, what we have to do, we have to find the current in short circuit along that line, and then once we find that current on that short circuit, then this current in short circuit, then RT will be equal to the voltage on open circuit at that part, which is our VT, divided by the current on short circuit on that line. Then we can find RT in that relationship. So if we want to use the second method, this is what we are going to have. We are going to have V1, this is our point A, R1, this is our point B, R2, we are going to have short circuit here, this is our point C, this is V2. Now, in this method, we want to find the current that is going on that line. So by looking at this circuit, we can see that our voltage at point A is equal to V1, and here our voltage at point B in this circuit will be equal to V2, which is 35 volts. At this circuit, when we have a short circuit. So here at the point B, we are going to have 1 over R1 multiplied by voltage at point B minus voltage at point A plus 1 over R2 voltage at point B plus this current in short circuit equal to 0. So if we simplify this, we can write this equation as voltage at point B multiplied by 1 over R1 plus 1 over R2 minus 1 over R1 voltage at point A is equal to minus ISC. So here we have all the values. We have the values for VB, which in this case is 35 volt. We have R1, R2, and we have the value for VA. So if we solve this, if we plug those values here and solve for IC, our IC will be equal to minus 63 over 12 will be equal to minus 21 divided by 4. Now that we found this ISC, we can plug it in this formula. RT will be equal to V at open circuit, which is the same as VT, minus 21 divided by ISC, minus 21 divided by 4. Signs will cancel out, 21s will cancel out, so RT will become 4 ohm. So we can use either method in order to find RT. In some cases, one method might be a lot easier than the other one. So it is up to you which method that you want to use. Now that we have now in this circuit we have VT, we have RT. The current that goes through this circuit, we can find out that current as RT multiplied by I plus R3 multiplied by I minus VT is equal to 0. So here I multiplied by RT plus R3 is equal to VT. So I will be equal to VT divided by RT plus R3, which VT we find out is minus 21 divided by RT is 4, R3 is 3 ohm. So divided by 4 plus 3 is 7. So the answer will be minus 3. So the current that goes through that Thevenin equivalent circuit will be minus 3. This is a very good example in how to find the Thevenin equivalent circuit. If you have any request, let me know and I will solve it for you. Thanks.